Hello dear students, hope you're doing well. So I will do some videos about your book, chemistry book, but be careful that I will just summarize the information that is given in your book, and we will not do exercises and basic questions. That will be for you. So listen to the explanation and afterwards solve your exercises and basic questions. And note, basic questions are really important and they do come in the exam. Okay, so this chapter is mostly memorizing stuff. I will explain it, and the things that you should memorize, I will tell you that you should memorize it. So first, let's start with safety rules. When you're working in the lab, because you're working with chemicals and it's dangerous, you have to be careful with some stuff. So we have 10 safety rules. Number 1, keep working areas clear of bags, books, and etc. Your personal stuff before you go to the lab, you have to keep them outside. Number 2, you have to listen carefully to the instructions the teacher or the lab assistant that they give you. You have to be careful with that. Number 3, work with care. Do not be clumsy and stuff. You have to be serious when doing an experiment. Again, because you're working with dangerous chemicals. Number 4, report any accidents, however small, at once. Whenever something is happening and it's not clear or something weird, even if it is small, you have to tell your teacher or your lab assistant. Number 5, wear safety glasses at all times. We call them goggles. Here they are. Especially when you heat stuff, to protect your eyes from high temperatures. Number 7, do not run, push, or act stupid in the lab. I knew guys, especially boys, so do not be so boyish and do your stuff carefully. Number 8, do not taste anything without permission. You can never taste or even smell chemicals. You have to be careful. We'll have certain ways on how to smell them, but tasting, you never taste them. Even if you know, for example, it's water, no. Maybe it's contaminated with the container that it is and you used chemical previously, so it's not pure water, for example. Number 9, do not smell a gas except with great care, even with great care, so be careful. How about do not smell anything, with permission or without permission, both of them. Number 10, do not try your own experiments without permission, without asking your teacher, without asking for a procedure. What do you mean by procedure? Procedure is a paper, step by step. It's explaining how you do the experiments. You do not just do any experiment you like. No, you follow the procedure. Next, we have some labels. When we have chemicals, we're working with them. On their containers, we have some labels. These are important for your AMS is the multiple choices, the bubble sheet. You have to memorize their pictures. So, for example, you will have 3 pictures and say which one of them is the explosion, for example. So, memorize the picture, read the meaning. Section 2, we have some chemical apparatus. These that are mentioned or that are given in the picture, the figure. All of these are chemical apparatus. You might have noticed that when you're in the lab, you have most of these in the lab, depending on what experiment you're doing, and each one of them is for a specific thing, and you have to be careful. You have to memorize which one of them to be used. So number 1 is a pipette. Pipette, you measure liquids, okay? But the thing is, we have a pipette and burette. We have both of them. So what's the difference between them? Both of them are used for measuring liquids. But pipette, we use it to measure liquids for exact numbers, meaning that we should have a whole number. For example, 10, 20, 15, and so on. But burette, we can use it from 0 to 50, meaning even we can have decimals. Okay, for example, 16.7. That's a decimal, it's not a whole number, so we can use a burette. Can we use a pipette? No, because it's not a whole number. But if I say 17, yes, we can use a pipette. Okay. Something else that we have with all of these apparatus, we have uncertainty, meaning that we are uncertain of our measurement about this much. For example, the first one, pipette, is to the near 0.05 centimeters cubed, meaning it's positive. This is how you measure, how you mention uncertainty, positive, negative. 0.05 cubic centimeters, meaning this whole number that you're measuring could be more or less by this much. Okay, because sometimes a drop or less a drop is remained in the flask or in the container that you're measuring with, especially the small ones. The second one for burette, 0.05 centimeters per reading, meaning if you only use it once. If you use it more than once for the same substance, it will become 0.1 cubic centimeters for the whole sample. Okay, and most of the time we do it more than once to be sure if we got it correctly or not. That's the first one, pipette. The second one, burette, both of them for liquids. Number 3, measuring cylinder. Okay, still for liquids, but big amounts of liquids, not like pure burettes and pipettes. But for if you want to be more specific, more precise, you have more precision, use pipette and burette. Because measuring cylinder is not that precise, it's not that accurate, so it's inaccurate. Beaker, we can use it to, again, for liquids, but it's not precise, just like measuring cylinder. And something else that we use it for is to be used as a container. For example, you're doing your measurement, you want a liquid to stay there, use the beaker. It's just a container, open container, we call it a beaker, and it's graduated with points. Put your liquid inside and leave it there. So use it as a container because it's not that accurate to be used to measure liquids. That's number 4. Number 5, conical flask. Again, we use it as a container. It looks like a beaker. Later on, we will have some of their pictures. It looks like this is a conical flask. Okay, this one. Still, it's inaccurate. Number 6, evaporating dish. We use it in crystallization. Later on, we will talk about the process. Number 7, volumetric flask. If you want to prepare a solution, meaning we want a solute to dissolve it in a solvent together forming a solution. Where do you put this? Where do you prepare this? We use volumetric flasks. Okay, they have different or specific volumes with different sizes. 250, for example, up to 1000, for example, sometimes 500, for example. The uncertainty is 0.1 cubic centimeters, so it could be more or less by 0.1 centimeter. Number 8, test tube. Test tubes, we just use it for small scale experiments. We want to do an experiment, for example, for 1 milliliter of a liquid. We want to do an experiment on it, we use test tubes. So we do not use it to measure anything. No, you're just doing an experiment on it. Number 9, boiling tube. It looks like a test tube, but it's bigger and harder than a test tube. We use it to boil stuff, for example. So using high heats. Number 10, separating funnel. When we want to separate two immiscible liquids, meaning we have two liquids that they do not dissolve into each other. For example, oil and water. They do not dissolve, they do not mix. So they're immiscible. How do you separate them? We use a separating funnel, and it's very easy to work with. 11, we use a funnel. We use it in filtration. Later on, we'll talk about filtration to separate a solid from insoluble solid from a liquid. Number 12, crucible tongues to hold stuff, especially when you're working with high heats. So to hold them, it looks like a scissor, but not exactly like a scissor because we use it to hold stuff. Later on, we will have some of their pictures. Number 13, test tube holders. Just like the name, it holds test tubes. Again, when they're hot. If they're cold, we do not need them. Just use your hands. 14, thermometer. We use it, you know this, we use it to measure temperatures. Because sometimes when you're doing an experiment, we need specific temperatures. So how would you know if you reached it or not? We use a thermometer with it. Number 15, the last one, wire gauze. We will have it later on when you heat stuff. If you want everything in the container to be heated uniformly, meaning the heat reaches everything in the container, we use this wire gauze. Okay, so these were some of the apparatus. Memorize them. their uncertainty, memorize them. Numbers, when to use each one of them, you have to memorize them. Okay. Later on, we have pictures, we have drawings. When we draw a chemical apparatus, we have to be careful that you should not be an artist when you draw them. We only use small lines or simple lines. They should be neat, tidy, they should be clear, you have to understand them. They should not be weird, so for everyone to understand, just like this. These are all the apparatus that you need with their pictures. Again, memorize their pictures or connect them. For example, we talked about funnel. We said that we use it in filtration. This is how it looks like. Okay, we talked about wire gauze. When something is heated in your thermal, you want it to heat everything with the same amount. You use wire gauze. Thermometer. This is crucible tongues to hold hot stuff. For example, boiling tube. It looks like a normal test tube, but it's bigger. This is it. Conical flask, evaporating dish, test tube holders. We talked about most of these. So memorize their pictures. Next we have the Bunsen burner. A Bunsen burner, what do you mean by Bunsen burner? When you want to heat something, this is the Bunsen burner, okay? This thing. It has fire with it, okay? So how do you deal with it? How do you use it? What are the steps that you should follow in order to use this Bunsen burner? Step number 1, you have to place it on a porcelain tile. You have this bench that you're working on it. If you want it not damaged, you have to put something, look, beneath this Bunsen burner. That's the porcelain tile to protect it, for the heat to not reach the bench. For example, if it is made up of wood, it will be catched on fire. Most of the time it's not made up of wood, but just for example. Number 2, make sure that the Bunsen burner is attached to a gas tap. Look, here it's attached to a gas tap, to qanina, for example, to gas cylinders. So we have this big thing connecting them. Number C or 3, make sure that the air holes, look here, it's open. It's not clear here, but it's open. Make sure that they're closed at the beginning, okay? Then hold the light match or the splint. You want to start the fire, right? Hold the light match or the splint right here on the muzzle at the top and open the gas tap. Okay, open this here until the fire is on. But be careful that you have to keep your face and hair away from it, especially if you have long hair. You have to tie it up and be careful with it. It's going to start. Next, slightly open the air holes until the flame is blue at the top. So here, when we closed it at the beginning, the air holes, open them now. When you want fire, you need oxygen in order for this fire to start. So open this for oxygen to go in, for fire to start. So open it until fire starts, until your file is blue at the bottom and slightly yellow at top. Not everything is blue. If everything is blue, close it and start it all over again, or adjust this air holes, because it's dangerous. Later on we'll talk about it. If a hot flame is required, you have to open this to the end. Open it all up because you need more oxygen, so it becomes a hotter flame. So we said that we should not have a blue flame. We should have blue at the bottom and slightly yellow at top. Why? Number 1, because it's more noticeable. You can see it. If it is blue, you cannot see it that much, so accidents might happen. Number 2, blue flame, it's more likely to go off with time. So for example, it's blue flame is there, then 10 minutes later it's off, and you have not switched the gas, you have not turned off the gas, so the gas is all going in the room and it's becoming dangerous. Because of these reasons, you have to have blue flame at the bottom and yellow at top, not entirely blue. So what safety rules you should follow? These are the steps. If the question asks you for steps to follow in order to start the Bunsen burner, mention these from A to F. If the question asks you for safety rules, we only have 2. Number 1, do not open the gas tab before you place the light match near the muzzle. For example, someone has opened this, then he or she goes and searches for a match. It will take time and the gas will go all over the place and becoming dangerous. So you should be ready with your match in your hand. Start the tab for gas to go in, then start the fire. B, never leave the Bunsen burner with a blue flame, and we talked about the 2 reasons why. Next we have heating a test tube. We have a test tube, you're doing an experiment, you want to heat it up, increase the temperature. What should you do? What are the steps? So what are the rules to follow when heating a test tube? Number 1, never have the test tube more than half filled. Look, it's even less than half, because when you increase the temperature, it boils and everything will go out if it is more than half filled. Okay. Number 2, always use test tube holders. Okay, and never tongs. We have tongs to hold other stuff, other apparatus, but for test tubes we have specifically test tube holders. Okay, and do not use your hands because again they will be too hot to handle. Number 3, do not hold the test tube upright, meaning just like this. This is the fire. Do not hold it up just like this. No, it should be tilted. Again, because you increase the temperature, it will boil and everything will go out. If it is inclined at an angle, just like this, it will not. Number 4, keep the test tube moving. When you're doing your experiment, keep it moving up and do not just stay like this, because if you stay like this, only let's say this portion will be heated up, but if you move it, everything will be homogeneous. Number 5, when the liquid starts to boil, strongly, vigorously remove it a bit, take your hand away a bit, then put it back for it to not spill out. These are the rules to follow when you want to heat a test tube. Heating a beaker or heating a big dish, an evaporating dish, what are the rules to follow? Again, we have the Bunsen burner. You attach it with a gas. We already talked about how to handle the Bunsen burner. We have the evaporating dish or the beaker here. What else do we have? You should put it on a tripod. This is the tripod. Okay, on this tripod we have this thing, the black thing. That's the gauze in order for heating to be homogeneous. We talked about this. That's number 1. Number 2, do not, again, just like the test tube, you should not fill it up to the end. It should not be more than half filled. Number 3, again, just like a test tube, you should, if you want to transfer this into somewhere else, you have to use, in this case, tongs. In the case of test tubes, you should use test tube holders for the same purpose, because they are too hot for you to handle them with your hand. Next we have crystallization. Crystallization, when we want to form crystals, to have crystals. So we have something dissolved in a liquid, you want to separate them. We have crystals, and for the liquid to evaporate, we can use crystallization. And we already talked about this, I think last year or no. So you can have two methods for crystallization. We can use it by cooling a pure liquid or by heating a solution. The easy stuff is just to heat it, increase the temperature, the liquid will evaporate and you'll have crystals at the end. So what are the steps? Number 1, heat the evaporating dish directly with the Bunsen burner, just as we talked about that here. The rules to follow them. Heat it, but do not boil it dry, meaning you should have, at the end, you should have some liquid left at the end. B, using tongs, transfer the evaporating basin to the steam bath. Okay, so now look, at the beginning we had this much liquid and something is dissolved in it. We want the crystals. After you evaporate it, you will have, let's say, this much liquid. Put this whole thing, this beaker, in a steam bath. So you have hot water. What will happen here? This hot water will increase the temperature of this liquid. It will evaporate, remaining the crystals there. Next we have units of volume. What do you use especially in the lab? We have many units, for example liters, for example milliliters, for example cubic centimeters, cubic decimeters. Know something, that 1 liter is the same as 1 cubic decimeter, and 1 milliliter is the same as 1 cubic centimeter. Okay, and the relationship between them, 1 liter is 1000 milliliter, or 1000 cubic centimeter, or 1 cubic decimeter, again 1000 milliliter, 1000 cubic centimeter. They're the same thing. Okay, next we have measuring cylinders. We already took this in I think grade 8. Yes, grade 8, the science tools and skills, the book that you guys hated. How to deal with it, how to deal with it. So measuring cylinder, when do you use it? When we want to measure volumes of liquids, okay, with great accuracy, not like a beaker, let's say. It has 0 accuracy. So the depending on the size of the sample you want, you will choose the specific measuring cylinder. So what are the rules to follow? Why should we be careful? What steps should you follow? Number 1, the way you hold it should be upright. Okay, not tilted just like this. No, upright, and put it on a smooth horizontal surface. Number 2, when you look at it, your eye level should be the same as the liquid, not up or not down. Okay, and you should in order to measure it, you should look at the meniscus. What does that mean? When you have a liquid, it's not just straight the top. It looks something like this, curved, right? So the bottom of the meniscus is on which point? That's your reading, not the top, not the straight top. Okay, we call this meniscus. Next we have filtration. When we want to separate a solid and insoluble solid, meaning it has not dissolved in a liquid, let's say sand and water, for example, you use filtration. What do you use here? You use filtering paper. It's a special kind of paper. We use funnels. So use the filtering paper, you divide it in 4 halves, then fold it into this shape, put it in the funnel. Okay, then attach it to a stand. At the bottom, if you want the liquid, just put a beaker in. We have the funnel and we have your sample solid in a liquid. Put it in. What will happen? When we have this paper, the solid will remain here and the liquid will go down up until it gets to this beaker. This is filtration. What terms do you use? We use filtrate and we residue. The solid that remains here, that's the residue, and the liquid that goes down, that's the filtrate. Next, we have measuring mass. We use balances, especially with chemistry and with doing experiments. We use electric balances to be precise, to be accurate, for our measurements to be accurate. We use electric balances, not normal balances, the one we use, for example, in supermarkets. No, we do not use that, because most of the time we measure solids from 1 gram up until, let's say, 5 or 10 grams, not more, sometimes less than 1 gram, so you need to be precise. We use a method, we call it weighing by difference. What does that mean? It means that, for example, we want a solid to measure the mass of a solid. You put it in the container, and let's say a beaker, we have the solid. First, you measure the beaker, we have the mass. Okay, then you put the solid in the beaker, we have another mass. Then our problem is we only want the mass of this solid. So what do? We have 2 masses, you subtract them. So you say M2 minus M1, or M2 in which we had both of them in, minus M1 in which we only had the beaker. Then you will get the mass of the solid. Next we have using a pipette. A pipette, when do you use it? It's designed to measure specific fixed volumes of liquids, meaning whole numbers. And the uncertainty is 0.05 cubic centimeters. What common capacities we have? What common sizes do we have? We have 5 milliliter, 10 milliliters, 25, and 50. You basically suck in water or the liquid in the pipette. We use a filter filler. We do not use your mouth. Again, you're dealing with dangerous chemicals. You use a pipette filler, something we attach it to the pipette. This pipette filler, it has 3 valves. We call them A, S, and E. Okay, or 1, 2, 3. So A, S, and E. A, when you want to suck in the air out, we have to empty it out. Is when we want to suck in the liquid inside. Now it's empty. After you get the air out from A, valve A, you use valve S to get the liquid in. Then you pour it, for example, you want to transfer it to another container, a beaker for example, you use E to empty it. So A, air out, S, suck in the liquid, put it in, E, emptying it out. Okay, it's easy. At the end, after you transfer it to the other container, a beaker for example, sometimes a drop or two will remain at the tip of the pipette. Just leave it there. That's why we have uncertainty. That's why we have 0.05 cubic centimeters. Okay, the last thing we have is using a burette. Burettes are just like pipettes to measure liquids, but not for specific volumes, meaning not for whole numbers. We can use it for decimal points as well. For example, you want let's say 16.7 or 15.3, you use a burette. Here in the burette, there is something you have to memorize, that each drop that comes out from the burette is exactly 0.05 milliliters, because we have questions about this thing. Then how to deal with it, how to fill in the burette. Number 1, you have to place the burette in a burette stand. So attach it to a stand, just like here. Okay, attach it to a burette stand. Okay. Then you put the funnel in. Then what do? We have the liquid, you pour it in, but be careful, slowly, not everything all at once, and up until it is close to 0-ish mark. Sometimes it could be more than this, but it's okay, just put it in up until it is at 0 exactly, or more than 0, because if it is more than 0, it's easy. Just open this valve slowly, step by step or drop by drop, up until it becomes 0 again. So at the end, if you want to be sure if you have it at 0.0 or not, place a white paper behind it. Your eye level should be the same as the level of the liquid. Again, be careful of the meniscus. The bottom of the meniscus should be at 0.0. If not, open this valve again, drop by drop, up until it is at 0. Then you use it. For example, you want, let's say 15 milliliters. You open this up until you get to 15 milliliters. You get 15 milliliters out. And these are some questions about them. So this was it for chapter number 1. I hope you guys understood it. I know I go very fast because we do not have time. And see you guys in the next one, inshallah.